Greetings, fellow YouTube viewers with literally nothing else to watch. If you are a subscriber to this channel, then you are probably also a subscriber to Wolfie6020's channel, and if you're not, what is the matter with you? Get over there and subscribe to him right now. But, regardless, you've probably noticed that he has talked quite extensively about equatorial mounts and how they cannot work on a flat Earth. And they're very descriptive, very eloquent, and I think everybody should watch them because it's perfectly understandable for anyone who thinks about it why it cannot work on a flat Earth. However, I thought I would throw my hat into the ring and try to explain as well, here with a video of the setup of my equatorial mount and hopefully a visual depiction of what Wolfie is talking about and why it cannot work on a flat Earth. So we're going to start with the setup here, and through the joys of stop motion animation with very limited frames, we will go through the setup here, and just like that I can make an equatorial mount appear. That is the Astro-Physics Mach 1 GTO mount on a Burley-Bach Planet wooden tripod. And the first step in the process is to add the counterweights to it. And you'll see them go on the pole at the far end, 1, 2, 3, 4. Have to be spaced out a little bit to get the balance right. And then after that, we open up the mount rings. Then we haul out the scope, place it in the rings, close the rings, and then give it a flip upside down and around so that it's facing southwards, perpendicular to the ground. That puts us in what is known as the Park 4 position, and it allows the software to know exactly the right ascension and declination the scope is pointing at for my latitude, as long as I have it correctly polar aligned. And to get it set there in Park 4, I have to use a bubble level on both axes to make sure they're perfectly level, because that's very critical. And finally, plugging in the cables. And first is the Ethernet cable, that blue one. Then the camera's USB cable. And then the power cables, one for the camera, for the cooler on the chip, and then one for the mount itself. Then it's lens cap off, extend the dew shield, and we are ready for a night of observing. And there it is from the opposite angle. You can see the cables, how they're hooked up on the camera there. I wind them around so they don't get tangled up. And this little gadget right here at the base of the mount is the right angle polar alignment scope, or RAPIS for short. And that is what I look through after it gets dark to line up Polaris so that the mount is properly aligned with the North Celestial Pole. And when you look down into the RAPIS, you see these concentric bullseye rings with a crosshair in the center. The crosshair is the location of the North Celestial Pole, or south if you're in the southern hemisphere. And those rings are where you position Polaris at a correct time. And that shows Polaris's correct offset from the North Celestial Pole at that moment. Or if you're in the southern hemisphere, you use the outer 4 rings, which would be the equivalent for Sigma Octantis, because it's a little bit further from the South Celestial Pole than Polaris is from the North Celestial Pole. And you'll notice those rings are labeled from 2010 to 2040, and that is because the alignment scope takes into account Earth's precession. So when flat earthers tell you that the stars don't move and they're perfectly fixed, well, no, they're not, because if you don't align them correctly on those rings, you will not get a correct polar alignment, and whatever you're looking at will slowly drift out of the field of view. So this is where I will end the slideshow, and tonight I was going to take the scope out and do some observing, but it was too smoky, so I filmed this instead and just put a pointer stick on the mount. And here is why an equatorial mount will not work on any representation of a flat Earth. Howdy, wanted to make this video to hopefully explain in a visual way what flat earthers are not getting by when we say an equatorial mount can track objects using only one axis of rotation, and why this would never work on a flat Earth. I have my Mach 1 GTO Equatorial mount here set up on the deck. I was going to bring it out, look at the stars, but it's just too smoky tonight, so I'm not going to bother, and I didn't want to drag out counterweights and everything else. So I've only taped a stick to the top of it, which is pointing in the same direction the scope would be if it was mounted in the rings. While I was setting up, too, I noticed on the deck we got some dangerously diverging shadows here. I mean, I better watch out, because the sun must only be about 100 feet away, given that. I mean, parallel shadows? Yeah, I don't think so. Anyway, so the mount is currently aligned north. I know where to set the feet on the mount to have it pointing north, whether I've aligned it on Polaris or not. And you can see the stick is pointing in that general direction. If I look at the shadow on the wall over there, you can see there's definitely a shadow cast. Now if I turn the declination axis to point over at the sun, and I'm going to have to slightly adjust the right ascension axis to get lined up because I don't have the tracking running. There we are. Now the stick is pointed basically right at the sun. If I turn back around with the shadow, you won't see the pointer at all, meaning that we are lined up with the sun. Now, as time goes on in the evening, as the sun sets, all that the scope needs to do, or the mount needs to do, is rotate around this right here, the right ascension axis. The declination axis doesn't need to move again at all. So, as the sun goes to set, it's going to follow this path. It's going to set behind those trees, and eventually it'll be pointing down over there. Now I'm going to have to disconnect the drive cable here to do this. It's another reason I didn't want to set everything up. As the mount would continue around, it would continue tracking the sun at the same 15 degree per hour rate that it had been all day. It would come around like this, and eventually it would wind up the following morning, if cords weren't an issue and if the mount software would let it do it, pointing right over here to the east, above my house, in this case, where the sun would be coming up. And it did all that without needing any other axis besides the right ascension axis. The declination axis wouldn't rotate at all. Now, the problem that flat Earth runs into is this. They say the sun is never below the horizon. They say that when the scope is pointing down at the dirt, like this, that's not really where the sun is, that the sun is just skimming the horizon off in the north, and that we just can't see it because of perspective. Well, if we were to point the scope at the true position of the sun, we would have to rotate the declination axis. We would have to bring it up to point at the true sun's position. We would have to rotate this axis as well to point northwards at the horizon. And therefore, that is why a flat Earth model cannot support an equatorial telescope. Because this would be true for all objects, the moon included. The moon, stars, anything you point at is going to have this same issue. Real-world objects on a globe model can be tracked rotating this axis alone. this one. You never have to touch the declination axis. And that's why when you point it at Polaris, there's almost no shift in the position. That's roughly where Polaris would be. 6 hours later, you follow it around. I really meant to say earlier there. Come over here. You're still pointing at Polaris above the roof of their house. 12 hours earlier. And I mess up again. I meant 12 hours later. If I don't break my stick. On the other side of the mount, still pointing at Polaris over the roof of their house. So that, in a nutshell, is why equatorial mounts cannot work on a flat Earth. On a flat Earth, since nothing ever goes below the horizon, the mount, in order to correctly point at their real locations, would have to, at some point, not point at the dirt. You'd have to rotate this axis as well. So there you go. Simple as mud, right? Thank you very much for watching, and I will catch you again very soon. Talk to you later.